Namaste my dear students, Nenu Mi Suryateja from Saimedha Ecet Coaching Center Koti, Hyderabad. Director JC Sir Advaryamlo, Shashikanth VALMIKI Sir Parvekshana నిర్వహిస్తున్న Saimedha Coaching Center Koti, Hyderabad. Ecet 2023 రాసిన విద్యార్థులందరికీ మీరు అబ్జెక్షన్స్ పెట్టుకోనికి వీలుగా ఉండాలి అనే ఉద్దేశంతో ఈసెట్ పేపర్స్ అన్నిటిని బిట్ టు బిట్ ఎక్స్ప్లెయిన్ చేయడానికి ఈ వీడియో లెక్చర్ సిరీస్ మీ ముందుకు తీసుకురావడం జరిగింది. కాబట్టి మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాశారో, ఎవరైతే క్వశ్చన్స్కి ఆన్సర్స్ తెలుసుకోవాలనుకుంటున్నారో, పూర్తి డీటెయిల్ ఎక్స్ప్లెనేషన్ ఈ వీడియో లెక్చర్స్ని ఖచ్చితంగా వాచ్ చేయండి. అలాగే మీ ఫ్రెండ్స్ అందరికీ కూడా ఈ వీడియో లెక్చర్ సిరీస్ని షేర్ చేయండి. దీంతో పాటుగా మై డియర్ స్టూడెంట్స్, ఎవరైతే ఈసెట్ 2023 రాశారో వీళ్ళందరికీ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక ద్రోణాచార్య బ్యాచ్ ని ఇంట్రడ్యూస్ చేసింది. గత 25 సంవత్సరాలుగా ఎంతో మంది ఇంజనీర్లు తయారు చేసిన సంస్థ సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ డిప్లొమా విద్యార్థులకి అండగా బాసటగా నిలవన ఉద్దేశంతో ఈ బ్యాచ్ ని మీ ముందుకు తీసుకురావడం జరిగింది. ఈ బ్యాచ్ లో భాగంగా మీ అందరికీ మొదటిగా మీరు బీటెక్ లోకి వెళ్ళిన వెంటనే ఇబ్బంది పడుతారు అనే ఉద్దేశంతో, ఆ ఇబ్బందిని పోగొడితేనే ఫ్రీ మైండ్ తో ఉంటేనే పని బాగా చేస్తారు ఉద్దేశంతో బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్స్ ని ప్రొవైడ్ చేస్తున్నాం. బీటెక్ 2-1 అకాడమిక్ సబ్జెక్ట్సే కాకుండా సిఆర్టీ క్యాంపస్ రిక్రూట్మెంట్ ట్రైనింగ్, దీనిలో భాగంగా ఆప్టిట్యూడ్, రీజనింగ్, ఇంగ్లీష్, అదేవిధంగా సిఆర్టీకి కావాల్సిన బేసిక్ కోడింగ్ లాంగ్వేజెస్ సి కావచ్చు, C++ కావచ్చు, జావా కావచ్చు, పైథాన్ కావచ్చు, వీటన్నిటిని మనము లైవ్ క్లాసెస్ ద్వారా అందిస్తాం. దీంతో పాటుగా థర్డ్ వన్ డిప్లొమా బేస్డ్ జాబ్స్ టెస్ట్ సిరీస్, మీరందరూ సంవత్సరం నుంచి కావచ్చు, సెకండ్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఫస్ట్ ఇయర్ కంప్లీట్ అయిన దగ్గర కావచ్చు, ఈ సెట్ కొరకు ఇంజనీరింగ్ సబ్జెక్ట్స్ బాగా ప్రిపేర్ అయ్యారు. ఇదే ఇంజనీరింగ్ సబ్జెక్ట్స్ అనేది మీకు రేపు డిప్లొమా బేస్డ్ జాబ్స్ కూడా ఉండడం జరుగుతుంది. కాకపోతే మీరు రేపు జాబ్ పడినప్పుడు రెడీగా ఉండాలంటే కన్సిస్టెంట్గా ప్రిపరేషన్ అది అవసరం అవడం జరుగుతుంది. కన్సిస్టెంట్గా మీరు ఆల్రెడీ మీ అందరూ బాగా ప్రిపేర్ అయ్యారు, మీకు సపోర్ట్ ఉండాలనే ఉద్దేశంతో ఒక టెస్ట్ సిరీస్ కూడా మనం ద్రోణాచార్య బ్యాచ్లో ఇంక్లూడ్ చేయడం జరిగింది. ఈ టెస్ట్ సిరీస్లో భాగంగా ప్రతి వీక్ టాపిక్ వైజ్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేస్తాం. టాపిక్ వైజ్ అయిపోయిన తర్వాత మనం మిక్స్డ్ టాపిక్స్ ఆర్ మిక్స్డ్ సబ్జెక్ట్స్ గ్రాండ్ టెస్ట్ కండక్ట్ చేస్తాం. ఫైనల్ గా ఓవరాల్ గ్రాండ్ టెస్ట్లు కండక్ట్ చేయడం జరుగుతుంది. 1 ఇయర్ పాటుగా మీకు ఈ డిప్లొమా బేస్డ్ జాబ్స్ యొక్క టెస్ట్ సిరీస్ కోర్స్ అందించడం జరుగుతుంది. దీంతో పాటుగా 2 ఇయర్స్ వ్యాలిడిటీతో ఆల్ ఓవర్ ఇండియాలో ఎవరు తయారు చేయలేని విధంగా మన సాయిమేధ కోచింగ్ సెంటర్ కోటి హైదరాబాద్ ఒక గేట్ కోర్స్ని రెడీ చేయడం జరిగింది. ఆ గేట్ కోర్స్ విత్ వ్యాలిడిటీ ఆఫ్ 2 ఇయర్స్ అందించడం జరుగుతుంది. ఈ 4 మాడ్యూల్స్ మనము ద్రోణాచార్య బ్యాచ్లో అందించడం జరుగుతుంది. దీని విలువ సుమారుగా ₹1,00,000. కానీ ఈ కోర్సు మొత్తాన్ని ఫ్రీ ఆఫ్ కాస్ట్గా అందించడం జరుగుతుంది. జస్ట్ ఈ 2 సంవత్సరాల మెయింటెనెన్స్కి, అదేవిధంగా టెస్ట్ సిరీస్ కోసమని రిజిస్ట్రేషన్ ఫీజ్ ₹3,000 అనేది తీసుకోవడం జరుగుతుంది. ఎవరైతే డిప్లొమా కంప్లీట్ చేసుకుని బీటెక్ వెళ్తున్నారో వీళ్ళందరికీ ఒక మంచి అవకాశం ఇది. కాబట్టి ఈ అవకాశాన్ని మీరందరూ ఉపయోగించుకుంటారని ఆశిస్తున్నా. మీరు ఈ అవకాశాన్ని వినియోగించుకోవాలంటే ముందుగా మీరు మన అప్లికేషన్ స్పేస్ గేట్ అనే అప్లికేషన్ని డౌన్లోడ్ చేయండి. డౌన్లోడ్ చేసిన తర్వాత అందులో ప్రొఫైల్ సెక్షన్ ఉంటుంది. ఆ ప్రొఫైల్ సెక్షన్ మొత్తాన్ని ఫిల్ చేయండి. ఫిల్ చేసిన తర్వాత మీ అడ్మిషన్ ప్రాసెస్ కోసమని 9848692598 ఈ నెంబర్కి కాంటాక్ట్ అవ్వండి. అడ్మిషన్ ప్రాసెస్ ఎట్లా, అదేవిధంగా ఇంకేమైనా కోర్స్ డీటెయిల్స్ ఏమైనా కావాలంటే కూడా పూర్తి ఇన్ఫర్మేషన్ అందించడం జరుగుతుంది. మై డియర్ స్టూడెంట్స్, మీరందరూ ఈ అవకాశాన్ని వినియోగించుకుంటారని ఆశిస్తూ నేను మీ సూర్యతేజ ఫ్రమ్ సాయిమేధ ఈసెట్ కోచింగ్ సెంటర్ కోటి హైదరాబాద్.
The function of steel wire in a ACSR conductor. So what is the abbreviation of ACSR conductor? Means aluminum conductor steel reinforced. Basically ACSR conductors belongs to composite conductor. Composite means is a combination of 2 material. In this particular conductor we are using of aluminum and as well as steel. The center strand is made up of steel, remaining all strands is made up of aluminum, right? Look at this. This material is a center strand made by steel, remaining all strands is made by aluminum. So what is the purpose of steel in ACSR conductor? That is a question is asking here. First option, compensate for skin effect. Second option, take care of surges provide the additional mechanical strength, and fourth one, reduce the inductance value. The center strand is made up of steel because there is only one reason, to improve the mechanical strength of the conductors. Basically, aluminum is a light-weighted conductor and mechanical strength of the conductor is very less. So just to improve the mechanical strength of the aluminum, we are using of what ma? Steel. Okay, steel is the main function of the steel is to improve the mechanical strength of the conductor. But in the ideal condition, the flow of current in the steel is zero, but practically some small currents are flowing in this conductor. But based on this information, tell me what is your answer? Provide the additional mechanical strength of the conductor, right? So 3 is the right answer. This is a theory oriented question ma. Let me check next question. The voltage at two ends of the line are 132 kV and its a reactance of 40 ohms. The capacity of the line is option 1 435.6 megawatts, option 2 217.5 megawatts, option 3 251.5 megawatts. Fourth option is missing, sorry. Okay, generally this is a single line diagram of our power system. This is a generation station and this is a transmission, just assumption, and this is the distribution line. Okay, this vertical lines representation of buses, right? These buses provide near to generation, that's why this name is called generating bus bar, and this bus is near to the load, that's why this name is called load bus bar. So what is the question given here? The voltage at two ends of the line. So this is the transmission line. The transmission line has contained two ends. One is a sending end and one more is the receiving end. But the both ends, the voltage should be same. That value is 132 kV, right? Sending end voltage is 132 kV and receiving end voltage is also 132 kV, and line inductance is line reactance is 40 ohms. Okay, whenever the currents are flowing this conductor, reactance is developed, right? Induct to reactance. This is representation by XL. This XL value is called 40 ohms. Okay, the capacity of the line. Okay, what is the capacity of the line? The maximum power transfer in the line, the formula is V square by XL. Okay, V square by XL. So both ends voltage should be same. That's why this is the V square, right? So 132 into 132, both side voltage should be same na. That's why 132 into 132. Okay, 132 into 132 by the reactance of the transmission line is 40, right? After simplification, this answer is 435.6 megawatts. So this is the formula. Okay, answer 1 is the right answer. 135.6 megawatts. Let me go into next question ma. The lumped inductive loads, with increase the supply frequency, option 1 P and Q. Here P for active power, Q for reactive power, right? P and Q is increases, P increase, Q decrease, P decrease, Q increase, and P and Q are decreases. Students, generally, so this is generation station, right? And this is the transmission line. The end of the transmission line, we have to start distribution line. Okay, transmission line, right? This is a generation, this is the distribution line. This vertical line representation by bus bar, this bus bar near to the load, this is the name is load bus bar. Load bus bar. What is the name? Load bus bar, right? Load bus. Okay, the load bus bar is given to the apparent power. This is the S. The load bus bar is given to apparent power. S is equal P plus JQ. Okay, here S for apparent power, P for active power, Q for reactive power. But in this question already mentioned, there is a lumped inductive load. Okay, here one load is connected, but the nature of the load is inductive load. Inductive load. So inductive load, what is the nature of the inductive loads? The inductive loads always try to observe the reactive power. Okay, pure resistive loads always taken as active power, but here this is a completely is inductive load, but there is no resistive load here. Only one inductive load. Always try to draw the reactive power from the load bus bar, right? reactive power. But one more information is already given mentioned, increase the supply frequency. Whenever the supply frequency increases, the inductive nature is increases. What is the formula for inductive reactance? XL is equal to pi FL, right? Okay, whenever the supply frequency increases, and what is the XL? Inductive reactance is also increases. If inductive reactance value increases, the inductive load try to observe the more reactive power. Okay, so then why? Tell me what is the answer? P and Q increases? No. Okay, pure inductive load always taken as reactive power, not for active power, right? So one is the wrong answer. Second one, increase the reactance, decrease the increase the P value, decrease the Q value. Okay, and 3, P decrease, Q increase. చూడండి ఇక్కడ మనం ఏం చేస్తున్నాం, ఇండక్టివ్ పవర్ డ్రా చేస్తున్నాం. అంటే ఈ లోడ్ బస్ బార్ నుంచి మనం ఎప్పుడు రియాక్టివ్ పవర్ తీసేసుకుంటున్నాం, అంటే రియాక్టివ్ పవర్ అనేది ఇంక్రీజ్ అయిపోతూ ఉంటుంది. whenever the reactive power increases, obviously this factor value decreases, right? So ఎప్పుడైతే factor reactive power decreases and power factor is also drop out. Okay, then what is the right answer? P decrease but Q increase, and that means load is always draw the reactive power, right now? So answer 3 is the right answer. P decrease, Q increase, right? Next question. The Faraday effect on long overhead lines expressed when it is dash. Generally, what is the statement of Faraday effect? Okay, the Faraday effect statement is at a medium and long transmission line, at light load or no load condition, sending end voltage less than the receiving end voltage. This is a statement or definition of the Faraday effect. What is the definition? Medium and long transmission line at light load or no load condition, sending end voltage less than that receiving end voltage due to the inductance and capacitance value in a line. Okay, but the Faraday effect occur due to the which condition? Light load condition, light load or no load condition, So here given options is given. Option 1, light load only, full load at unity power factor, full load at 0.8 power factor, and for all loads. No, first is the right answer. The Faraday effect only occur in the no load condition only, not for full load condition. Okay, okay, this is the concept, Faraday effect. So 1 is the right answer. Next, the presence of earth in case of overhead lines. Okay, so this is the just assumption of this is the transmission line. We are consideration of earth. We should be considered earth, and one more capacitance is formed if we have to consider earth also. One more capacitance formed, that is called earth capacitance. Okay, this capacitance is developed in between line and as well as earth. Okay, the presence of earth in case of overhead lines. Okay, option 1, increase the capacitance value. Yes, obviously. Okay, generally in the transmission line, line to line capacitance is formed like this. This is the R and Y, in between one capacitance form. If suppose the earth should be also considered, one more capacitance is formed, that is the earth capacitance. Overall, enter the transmission line, the capacitance value is increases because we should be consideration of earth also. Okay, so the presence of earth in case of overhead lines, అదే చెప్తున్నాడు, ఎర్త్ ను కూడా నువ్వు కన్సిడర్ చేస్తే ఇంకో కెపాసిటెన్స్ ఫామ్ అవుతుంది, దట్ ఈస్ కాల్డ్ ఎర్త్ కెపాసిటెన్స్. ఈ ఎర్త్ కెపాసిటెన్స్ వల్ల ఓవరాల్గా లైన్ కెపాసిటెన్స్ కూడా ఇంక్రీజ్ అవుతాయి, రైట్? సో ఇంక్రీజ్ ద కెపాసిటెన్స్, ఇంక్రీజ్ ద ఇండక్టెన్స్, decrease the capacitance, decrease the inductance, right? What is the right answer? Increase the capacitance. But we should be considering at the capacitance, there is no changes of inductance value. Inductance value, there is no change. Okay, inductance is only depends upon the current, not for voltage, Okay, if sudden change of currents flowing in a line, the formation of inductance, which opposes the sudden changes of current in a line to formation of inductance. Inductance it depends upon the current, but capacitance depends upon the voltage. Voltage means potential difference, right? So one is, this is taken as high potential, earth is also taken as low potential, in between to formation of one capacitance, that is earth capacitance. Due to the earth capacitance, overall enter the total capacitance also increases, right? So increase the capacitance value, right? So 1 is the right answer. Inductance of the transmission line is minimum when? Inductance of the transmission line is minimum when? Generally, how to solve this question ma? By using a direct one formula is there. Okay, inductance per phase, this is the 3-phase transmission line. In 3-phase transmission line, first we have to find out the inductance per phase. The formula is 2 into 10 to the power of minus 7 ln. Ln means logarithmic ln of GMD by GMR. This is the formula for inductance per phase in 3-phase transmission line. So based on this formula, we can observe the one point. Inductance is directly proportional to the GMD. GMD means geometrical mean distance, and inductance per phase is inversely proportional to the GMR. So what is the question is given here? The inductance of the transmission line is minimum. Okay, inductance in the transmission line minimum. Okay, then GMR value increases, but inductance value of the transmission minimum, GMD value decreases. Okay, GMD is decreased, but GMR means geometrical mean radius value is increased. GMD decrease, look at this fourth option, GMD is low, GMR is high. So fourth is the right answer. Fourth one is the right answer, right? Let me see next question ma. In order to lightning discharge current is option. Okay, in order to lighting discharge of current is dash. 10,000 amperes, 1 ampere, 100 ampere in micro amperes. Okay, generally the transmission line lighting strokes are occur due to interaction of the two clouds. Okay, one cloud is taken as a positive cloud and one more cloud is taken as a negative cloud. In between the two clouds, some attraction force. Due to that, the two clouds are strike to each other, right? Are colliding each other. So due to colliding of action to produce the one current, that current is called surge current. Surge current. The surge current is the magnitude is very high. Okay, the surge current magnitude at ideal condition. Ideal condition means it is a space simply. In ideal condition, that value is 10 kilo amperes to 90 kilo ampere. The magnitude of current is very high, surge current. That's why these lighting strokes are very dangerous, right? And in practical cases, that value is 45 kilo ampere of currents, right? So based on this information, tell me what is the right answer ma? Discharge current is also called as a surge current. The surge current is developed interaction of the two clouds. Okay, the interaction of the two clouds to develop the surge current. The surge current is travel low potential. So earth is a low potential. The surge current is always travel towards the earth. This is called as lighting stroke, right? So students, 10,000 amperes is the right answer. Nearby value, right? 10,000 ampere is the right answer. Next one. The feeder is designed mainly from the point of view. Okay, general distribution lines, right? Suppose we take the small example, 11 kV by 440 volts distribution transformer, right? So this is a one transformer here, right? The incoming voltage is 11 kV, outgoing voltage is 440 volts, right? 11 kV by 440 volts, right ma? 440, this line name is called what ma? This line is called what ma? Distributor, and this line name is called what ma? It's a feeder. This line name is called feeder. Okay, what is the major difference between the distributor and as well as a feeder? Every consumer to draw the electrical power from the distributors only. Okay, with tappings, any consumer, not only any consumer, like domestic, industrial, commercial, whatever may be, every consumer to draw the electrical power from the distribution line. This is the as per nominal nominal names. This feeder is also called as primary distributor, and distributor is also called as secondary distributors, right? every consumer to draw the electrical power from the secondary distributors only. Okay, every consumer tapping like this. Okay, from distributor without any tappings is called feeder. Okay, there is no tappings in a feeder because this is a primary distribution line. Okay, so the consumer is not draw from the feeder. That's why each and every line the flow of current is same. That is the reason. The feeder design depends upon flow of currents, right? But the distributor design depends upon the voltage drops. These two questions are very, very important. Distributor means with the tappings, feeder means without any tappings. So there is no tappings in the feeder. The flow of current from input to output is same. So that is the reason the feeder design depends upon the current carrying capacity, right? So 1 is the right answer. It is current carrying capacity is right answer. Voltage drops, that is based on the distributor. Operating voltage not correct. Operating frequency is also not correct, right? Look at the next question. Corona losses increases with dash. Okay. Option A, decrease conductor size and increase in supply frequency. Increase both conductor size and supply frequency. Decrease in both conductor size and supply frequency. And fourth one, increase in conductor size, decrease the supply frequency. Students, what is the definition of corona? Corona nothing but simply the ionization of air. The ionization of air is called as a corona. Okay, surrounded conductor nearby air is start the ionization. Due to that, okay, there are three phenomena occurring in the transmission line like ozone gas, violet glow color, and easing noise. This symptoms is called as corona. Okay, look at this formula. This is the corona losses or power losses. Mainly the corona occur in a transmission line, huge amount of power loss are occurred. This is the formula for power losses due to corona. 241 in 10 to the power minus 7 F means supply frequency plus 25, there is a number by delta for air density factor, and root of R by D. R means a radius of the conductor, D means distance between the two conductors, and V0 is a phase voltage, Vc is a critical disruptive voltage. What does that mean by critical disruptive voltage means is a minimum phase to neutral voltage at which to formation of or initiation of corona is called as critical disruptive voltage. So ikkada corona losses is increased due to when which condition corona loss is increases, right? So first one, the power losses or corona loss or power loss directly proportional to the frequency. Whenever the supply frequency is increases, then obviously corona loss is also increases, right? Increase the supply frequency is right answer, right? And one more, decrease the conductor size. Yes. Okay. So here look at this. This is the formula for critical disruptive voltage. Okay. Here M0 means irregularity factor, G0 air dielectric strength, delta air density, R for radius of the conductor. Critical disruptive voltage is directly proportional radius of the conductor. Radius of the conductor increases, critical disruptive voltage is also increases. Critical disruptive voltage is increase. Whenever the critical disruptive voltage increases, but power loss due to the corona decreases. And simply the relation between the critical disruptive voltage and power loss is inversely proportional. Okay na? So ikkada chudamma corona loss increase avvali antadu. Corona loss increases means power loss increases, critical disruptive voltage decreases, critical disruptive voltage decreases, radius of the conductor decreases, right? And children, look at this, decrease the conductor size. Whenever the conductor size means radius of the conductor means size of the conductor, right? Radius of the conductor increases, critical disruptive voltage decrease, then phase power loss due to corona is increases. That is a relation is inversely proportional, but this is the only explanation. That is the reason I am not going to the in-deep discussion. Simply question to answer. What is answer? Supply frequency increases and decrease the conductor size. First one is right answer. Okay, first one is the right answer. But don't consider here because this is not a this is just like a ratio, not pure radius of the conductor, not pure distance between the two conductors. That's why I am not considered here. Just this is a ratio of radius of the conductor and distance between two conductors. That's why I am going to the critical disruptive voltage. So first one is right answer. Next, Which type of brake is suggested in electrical train? This question belongs to electrical traction system. Which type of braking is suggested in electrical train where the equivalent of inertia motor load system is high? Here some options is given: plugging, dynamic braking, rheostatic braking, and one more is a regenerative braking. Generally in the electrical traction system, to control the speed we are using of electrical brakings, and finally trying to stop we are using of mechanical braking, right? So electrical braking broadly divided into the three types. One is a plugging, and one more is a rheostatic braking, and third one is a regenerative braking. Most of the electrical traction system we are using of regenerative braking. Regenerative braking means the supply is written from the wheels, okay, or track, whatever may be. So that is called regenerative braking. Okay, so answer fourth one is the right answer. In electrical traction system, not only electrical traction system, even though presently we are using of electrical bikes and electrical brakes, electrical bikes and cars, that vehicle also we are using of regenerative braking, right? But generating voltage from the wheels very small, right? That is a simply regenerative braking is the right answer. Next question: which among the following statement are true related to the traction? High starting torque, series speed torque characteristics, complex speed control. Here some options is given: statement A only right, statement A and C is right, statement A and B right, statement B and C is right. Generally electrical traction system, it requires some characteristics. That is ideal conditions of electrical traction system. First, the required characteristics: high starting torque is required. Due to the high starting torque, to pull the heavy loads also, right? High starting torque and speed control. Generally in the electrical traction system, we are using of a series motor. Series motor, the main advantage is high starting torque and variable speed motor, and we can easily to control the speed by using different speed mechanisms, right? So look at this: high starting torque is required, it's very important in electrical traction system, and series speed torque characteristics is also increased. Whenever the speed increases, torque value decreases, right? Okay, and complex speed control, by using of series motor we can easily to control the speed. If the complex speed control, that is very dangerous condition. Okay, easy speed control is required in the electrical traction system. So C is not correct. A and B is right answer, right? A and B is right answer. It required high starting torque and series speed torque characteristics very important. Whenever the speed increases, then obviously torque value decreases. The relations are between the speed and torque is both are inversely proportional, right? Next one: during the dash period, the power supply to the motor is cut off and train allowed to run due to the own momentum. Okay, the speed characteristics of the electrical traction system is have representation of like this. Okay, this is the x-axis here taken as the time period and y-axis taken as speed, right? That is representation will be later speed. Okay, this speed time curve characteristics divided into around 5 periods. One is a notching acceleration period, and second one is the constant acceleration period, and next third period is the free running period, and fourth period is the coasting period, last period is the braking period, right? So look at this 0, T1, T2, T3, T4 and T5, totally 5 period. So 0 to T1 is a notching acceleration. In this particular period it required high starting torque, notching acceleration period, and second one is a constant acceleration period, second period, that is a T1 to T2 constant acceleration period, and third one period is called free running period. So in this particular period the train always run the constant speed, free running period. Okay, constant speed, and this particular period the train reached to the maximum speed also, right? In this particular period the train is always to run the constant speed. After the ending of the free running period we start the coasting period. coasting period. In this particular period, the supply disconnected from the train is moving own movement of inertia, that is the coasting period. The end of the coasting period, just to apply the brakes, finally the train will be going to standstill position, right now. So what is the question is given here? During the dash period, the power supply is to the motor is cut off, right, and the train allowed to run to own movement of inertia, that is the coasting period. In this particular period, the supply disconnected from the train and the train is going to the own movement of inertia, that is the coasting period. So what is the answer? 3 is the right answer. 3 is the right answer. The coasting period is right answer. Next one, 51. Next 179 question mark. The speed time curve urban services has no. Generally depends upon distance between the two stations. Distance between the two stations. Our services are divided into the 3 types. One is the urban services, and second one is the suburban services, and third one is the mainline services. The distance between the two stations just below 1 kilometer, that is the urban. So 1 kilometer to up to 8 kilometers, that is the suburban, and more than 10 kilometers is the mainline services. But what is the question is given here? The speed time curve of urban services. Urban, the distance between two stations just 1 kilometer. Within the 1 kilometer, to trying to maintain the constant speed is very difficult. That's why in especially urban services, we are missing one period, that is a free running period. Only acceleration period and coasting period. The end of the coasting period is braking period. Only 3 periods is there, right? So this is the alpha, that is acceleration period, and beta, that is a retardation period, and beta C is a coasting period. This is not a free running period. In this particular period, the supply disconnect from the train is going to the own movement of inertia. But in this 3 period, which period is missing? The free running period. So in this free running period, it's very difficult to maintain the urban services because the between the two stations just 1 kilometer na. Okay, so that means there is no free running period. 1 is the right answer. Okay, urban and as well as suburban, both the services character should be same. That is the reason in the both two services free running period is missing, right? So answer is free running period is right.